car drives from the starting position of x equals 0 and t equals 0, and its position changes with time according to this function here, where we have two constants a and b given here. And what we're asked to do is calculate the average velocity between t equals 0 seconds and t equals 10 seconds, and then calculate the instantaneous velocity at 3 different points in time. So we can start with A. And I've drawn this scenario out here where our car starts at the 2 starting points and it ends at 10 seconds. So our average velocity is just our change in position over our change in time from the start to the end point, which is x2 minus x1 over t2 minus t1. Now looking at this, we know x1, we know t1, and we know t2, but we don't know x2. But up here we have an equation for x, where x is equal to this. And we want to find our our position at t2. So we can simply plug in t in this equation, t equals 10 seconds, to solve for our position at that time. So x2 is equal to this equation with 10 seconds plugged in. So I'm going to write our a value, which is 5.2 meters per second cubed, times 10 seconds cubed minus 1.3 meters per second times 10 seconds. And plugging that into your calculator, x2 works out to be 5,187 meters. And now using that, we can plug this x2 in for this x2 and solve for our average velocity. So that's 5,187 meters. And I'll add the minus 0 just for completion's sake. Then t2 is 10 seconds. So that's 10 seconds minus 0 seconds. And that gives you an average velocity of 519 meters per second. And I didn't specify in the question, but in my drawing, I've got the car moving in the east direction. So I'll just call this plus x. And just so we make this a velocity, instead of just a speed with no direction, I'm just going to say that this is the velocity in the i-hat direction, which just indicates along the x-axis in the positive direction. And that is our average velocity between 0 and 10 seconds. Now we're asked to calculate the instantaneous velocity at 3 different points. So first, before we find it at certain points, we need to find the derivative of this equation. So what is the derivative of this? Well, we have just terms with powers, and so we can use our power rule, which the power rule for derivatives says that if you're taking the derivative of a term with a power n, then that derivative is equal to the exponent n times your variable with the n minus 1 power. So that is the power rule we're going to apply to this equation, which gives us 3at squared. So we're pulling the 3 out front and subtracting the 1 minus b. And so the variable goes away entirely in this term because this exponent is essentially a 1. You're pulling the 1 down, which is just b, and then 1 minus 1 is 0, and so you have no variable anymore. So this is our derivative equation. And now it's simple. We just plug in our values of t here. And this will be our instantaneous velocity, which I'll put a sub ins. So v sub ins and I'm going to draw a big line here at t equals 5 seconds. That line with the t equals 5 just basically is just a notation saying we are calculating this at 5 seconds. So now we're plugging 5 seconds into here. So it's 3 times 5.2 meters per second cubed times t squared, so 5 seconds squared, minus our b value of 1.3 meters per second. Meters per second. So our velocity at 5 seconds turns out to be 389 meters per second. And it's still going in the same direction, the I-hat direction, so I will put that unit vector at the end. Note this is a very fast car. Um, Cars don't usually go this fast, but that's just the way it worked out with the numbers I chose. Okay, let's do it for 10 seconds and then 15 seconds. Instantaneous velocity at t equals 10 seconds. Same thing, we plug in our 3 times 5.2 meters per second cubed times 10 seconds squared minus 1.3 meters per second. And at 10 seconds, that gives us an instantaneous velocity of 1,559 meters per second. And I'm going to run out of room over here, I think, but 15 seconds. If you just plug in the same as you did here, I'll let you do it yourself and see if you get the same answer. Will give you 3,509 meters per second with an I-hat. Okay, and notice one more thing. The units in this term is in meters per second. So we need this term to be in meters per second, and you have a second squared and a seconds cubed. So those seconds squared cancel out with this, with 2 of these seconds, and you get meters per second. So that was one example where we calculated both our average velocity and our instantaneous velocity. Thank you for watching.